Hello, one more day. Today is day 10 of the Advent of Code 2022. And it took me a long time to get to my computer today. So I read this statement in the morning and I will start coding now at night. Let's go ahead and read a little bit the statement. We have a list of operations, additions, and no operations. Let's copy the input. It's not so long. We can see it's not so long. So 10.in, let's paste it and quit. So what these operations mean apparently is that there is an X register. Let's see where this is explained here. There is an X register to which we add these numbers or we do no operation. The no operation takes one cycle and the add takes 2 cycles. What we want to know is the signal strength, which is the multiplication of the cycle and the X register at these moments. Okay, so what we want to do, let's see, sorry. What we want to do, first of all, we want to read the instructions, right? So the instructions are, let's do this. So line.split 0 int of line.split 1 for line in open 10.in. Let's print, sorry, something is not well indented here. Yeah, this is a tuple. So let's print the instructions and run it. Leaks index out of range. Let's, oh, sorry, that this only works if there is a, so if there's only an integer if it's an addition. So let's just do this. Let's change this completely. So this is just open 10.in .read .split lines. And we're done. These are all the instructions. Okay. So what we're going to do, let's have a function which says what could it be? Let's call it simulate for now. And we have these instructions. Well, and we have the X register. So what does simulate do? Simulate will give you, we have the X register is initially 1, says this statement. And I think what we want to do is for instructions or instruction, what we want to do is if. So the first thing we need to do, we need to know is that, so in the addition, the operation takes 2 cycles, and after the 2 cycles, the X is increased. So what we want to do, I think what we want to do in this cycle equals 1. So what we want to do in this function is yield the pair cycle X for each instruction. This is all the no operation does. Then we do cycle plus equal 1. It's very important that we get this order right in this problem. And then what we can do is if instruction dot starts with, for example, add X, then we could say n equals instruction dot split first element or the second, sorry, and we convert to an integer. And what we do is, again, we yield the cycle X because it takes 2 steps, cycle plus equals 1. And then we do x plus equals n. If this is right, we could have a list of simulate, which would generate all of the pairs cycle x. These are all the pairs that we get. So first is 1, second is 1, third blah blah blah. And then in the end, we want to have this cycle. So we want to know for I in this list, which is 20, 60, 100, 140, this, this. Let's print li. See what we get. Okay, it's 1 ahead, so we need to take 1 less. So what we want to do, so the solution 1, or sorry, here, part 1 equals 0, and we need to sum I times L of I minus 1. I think that is what we want. Print P1. Okay. Int untuple. Well, this is Li minus 1. 1. First we have the cycle, and then we have the value. Let's submit this. Okay, we got the gold star. So no need to think more. Let's read the second part of the problem. I haven't read it yet. It's clear we can improve this code a little bit, or I have some ideas on how to improve this code, but let's check the second part first. This one I haven't read before. So it seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of that sprite. Okay. There's no such thing as a vertical position. Like the CPU, the CRT is tied closely to the clock circuit. The CRT draws a single pixel during its cycle. Okay. Representing each pixel of a screen as a this. So cycle 1, cycle 40, cycle 41, cycle 80. Okay. So by carefully typing the CPU instructions on the CRT drawing, you should be able to determine whether the sprite is visible the instant each pixel is drawn. Okay. I don't really understand. Render the image given by your program. What 8 capital letters appear on your CRT? Okay, so we need to draw an image here. So how do we draw this? Like the CPU, the CRT is tied blah blah blah, single pixel during each cycle, representing each pixel of the screen as a. By carefully the CPU instruction the CRT drawing, you should be able to determine whether the sprite is visible in the instant each pixel is drawn. And how do we know if it is drawn? A lead pixel, if the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lead pixel. Otherwise, okay, let's see. I don't really understand this explanation. So sprite, okay, the sprite has 3, adds 15, draws pixel in position 0. Current CRT row. During cycle 2, CRT draws pixel in position 1. Finish executing, add 15. Okay. Current CRT row. Oh my god, I'm not understanding. I'm not understanding this at all. Allowing the program to run the completion causes the CRT to produce the following image. Okay. Let's go back. So let's see the explanation again. The CRT draws a single pixel during each cycle. Okay. representing each pixel of a screen as this. Here are the cycles during which the first and last pixel in each row are drawn. Okay, so in the first cycle, this one is drawn, this one is drawn, this one is drawn, this one is drawn. Okay. So by carefully timing the CPU, blah, blah, blah. Okay. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. Okay, so this one is drawn. Okay, I understand. So the screen is the following. Is a list of this, times 40 for this in range 1, 2, 3, 4, 5, 6. Print screen. Okay, that is the screen. What we want to print specifically is this dot join line for line in screen. Sorry, no, this is not right. Okay, so list of this, is that right? Okay, and we want to print this with a new line join. Okay, so this is the screen. Instead of doing this, let's write it unlit. Okay, so this, we can remove these prints here. We can remove this here, and we can assert p1 equals this. Okay, now in this simulation, what we want to do is for well, we could even say cycle x for in L. We can change this name later. What we have to do is we have to say if. So the position is cycle modulo 40. So it's the remainder of dividing by 40, because it will be 40 at most. At cycle 40, then it goes back to 0. It would be nice to know if whether this position is position 0. Yeah, it's called position 0. So it's not position 1, but position 0. Okay. So with this position, if position in x minus 1, x plus 1, then screen in the row cycle divided by 40 position equals this. Okay, that is what I get. Here it says what 8 capital letters. These are not capital letters, definitely. So let's see. Maybe it is shifted a little bit, or maybe it is just wrong. So let's print this L again. Okay, 240. So what we have to do is the CRT draws a single pixel during each cycle, representing each pixel of a screen as this. Here are the cycles during which the first and last pixel in each row are drawn. Okay. So by carefully timing the CPU, blah, blah, blah. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. Otherwise, the screen is dark. The first few pixels goes like this. So here we would lit this one, we'll list this one, then this goes to 15, so we start doing all these pixels. Okay, so I think this is wrong. This is not what we want to do. Well, I think it is what we want to do, right? And we said that X sets the horizontal position of the middle of that sprite. I don't know if it could be that we have somehow this shifted. No, that doesn't look better. And if we set, instead of -1 plus 2, okay, now that looks better. So let's see what letters do we see. We see R, E, H, P, R, L, U, B. And we got the gold star. Okay, so I think this is not exactly the problem. The problem is that position is this +1. Is that right? No. Well, yeah, maybe. So maybe it is what we want to do is x plus 1, x plus 2. This is what we got, right? So we will think a little bit later of what this means. So let's go back to the problem and try to reformulate this a little bit. So here we could also do let's say cycle x equals 1 1. Could put this in a single line. Makes sense. These instructions, we could just say it of, you know, line in open 10.in. Why not? Line. We don't really get much of reading this beforehand. So here we do this yield. I wonder if this would work. No. It's interesting. I was just trying the use of this walrus operator, but this is not how this works. Okay, so if line starts with add x, we could have this, or we could say in. There's different ways. So anyway, the n is here. We could also just add this, you know, just instead of reading and parsing, we just do this. So this, we have to do this twice, the yielding of the cycle and the x. So I think, do we need this extra parenthesis? No. So we can just remove that. Fine. So what we're doing in this simulation is we start with the cycle and the x, and then for each instruction, what we're doing is first, either if it's an add or a non operation, we always just the x value is not modified yet, and then we just increase the cycle. Then what we need to do, if there's an addition, we need to give another cycle because this operation takes 2 cycles, and then we spend another cycle having the same x, we increase the cycle and we modify the x. And then in the next cycle, which will be here, we will already yield the new value. Okay, so I like this. I think there is not a much better way of doing this. We could, instead of having a function and having a list and having this yield, we could probably say read input and run simulation. So we could just do this here. And how could we call this function? this so we could call this excess. There's one thing which is that the cycle we don't really need. So the cycle in this L that we're using, we use this cycle X. We could call this enumerate. I'm doing too many changes all at once. Let's go back here. So what would happen if I set cycle in enumerate L, and in L we did not, we just okay. So this is not working for some reason. Maybe this is -1. Exactly. Okay, so this makes more sense. So now we're only yielding the L. Then we have here what we expected in the beginning. This is there's a famous quote that there's 2 or 3 hard problems in computer science, right? And one is errors from one-off counting errors, right? And this is clearly a difficult one. So let's go back. So what I was trying to do here is, instead of having this yield and this list and so on, just have this, let's say, excess list, and we do this, and here we excess.append x and excess.append x. We could make this lowercase. So now this L we don't need. Substitute XS. And this list again, substitute XS. Okay. So now here we could say read input and run simulation. That's what we're doing here. We have this excess.append, blah, blah, blah. Then part 1. So part 1, well, part 1, of course, it can be done as a sum of this I times blah, blah, blah for I in this list, which we could say it's always, which in fact, well, let's make sure this assert is working. And this is range 2021 40. Is that right? That is right. But I don't think that's what we want. I think it's better to just have the list. Could be an arbitrary list. That is clear. Okay, so part 2. For part 2, we have an empty screen in the beginning. I think this is the right way of doing it. And then what we want to do is, for cycle X in enumerate XS, position is this. So the position is the cycle, the modulo 40 of the cycle. This 20, 60, 100, that's interesting. These are all the middle values, right? So we have 1, 2, 3, 4, 5, 6. This is just the middle value for each on each row. It's interesting. This is like the middle column. So what we're doing here is times 40 I mean, we could have some kind of constants like width, height equals 46, right? So we could have here width, and here we could have height, right? And this is the position. Here it could be width I times width divided by 2 for I in range height. Assertion error. Let's print this. For I in range height. So this is 0, 20, blah, blah, blah. So it would be I plus 1, right? Is that what we want? I plus 1. So this would be 20, 40. No, I'm not doing this right. This would be this time was width plus width divided by 2. I think this is an unnecessary complication, right? So we could do it like this, and we could put it here, this width and height. Just width and height 46. If position blah blah blah, this is equals this. So here we could also make this so some kind of validation that we're doing this right would be to do, say, this if this else dot. This way we would make sure that we are going through all the elements of the list, because initially this is an empty list, and then here we are setting this either this character or the dot. I don't know. You could argue that this is a more complex line. It is a single line, but it's a longer one, and it is just better to have it to do it this way. I could buy also that. So maybe let's leave it here. Let's leave it here. Okay, so this is part 2, and in part 2 we print. And when we print, we update this. What is it that we submitted? This is what we submitted, right? Solution, this. Okay, I don't know, this width and height, you know, we could just forget about it. 6, you know, 40. It's a magic number that appears 3 times. How magic is that? Let's leave it in this. Okay, so that's all for today. I don't know. Well, as I commented, I wrote this. I read this problem, sorry, before some hours earlier. The part 1 was pretty clear that the important thing here is ordering this in the right way. We didn't even need to process the no operation option, right? If there's a no operation, we just do this, and if there's an addition, we do an extra cycle. Let's comment then the lessons learned. I think one important thing, there isn't much to it. So one thing that we did is in the creation of the how to create a list of lists. So we had to use this trick. We used this trick, sorry. What else did we do? Well, we let that off by one. Errors are some of the hardest issues in computer science. So that is true, and you will find it many times. This is one important issue. Then I don't know what else. There isn't much like important using of Python. We used the modulo with and the integer division with to calculate the row column which we needed to print. And what else could we say? What else could we say? I think this is it. There isn't much more. It was just running a simulation, printing the solution. Is there anything else we could comment? Is there something else we could simplify? I don't know. This looks pretty easy to me, pretty simple. This, of course, we could say, what x else equals this. Save one line, doesn't make much sense. Append cycle plus one, append cycle plus one, update the x. We could, in the statement, x is uppercase. So I think it makes more sense to have this x as uppercase here than to have even the x's, this list uppercase. So I will keep that as uppercase because that's what the statement says. And here the screen, we initialize it. Then we enumerate all of the x positions that we have generated, get the position. This position, we could call it, well, I think this is fine. Another way we could do, okay, let's explore a different way of doing this. So here we could say for I in range height, for j in range width. So this is a different way. What we would do is the position. So we would do if x's, what would that be? I times width plus j. So let's say, that would be the x, right? So the cycle here would be this one here, right? And the position is j. So it would be if j in x's cycle. Let's do this, right? -1 x cycle or x cycle plus 1, then screen ij equals this. Okay, so this code here is strictly equivalent to this one here. And another way of doing this is j minus this less than 2. Okay. And the cycle here, it's I times width plus j. So this is a different way of doing exactly the same. It is for lines, so you could argue which one seems to be, and of course this one is the same as abs of position minus x less than 2. So as you can see, we're running both things, and then they all match, they print the same supposition. So what do you think is easier to do, this one or this one? I think for me it was more easy to come up with this, it was easier to come up with this solution because you're just iterating through all the x's. But here it is true that we are just having a range for its height, for its width, and then we do this. So even if we want to go, I will keep this second one. So if we wanted to go crazy, and this is not a good refactoring, I think this is the most understandable thing to do. Okay, but we could do something else. We could do the following. For I in range height, remove this. So for I in range height, and here we would do for j in range width, this is this if this else dot print screen. Of course this would not work. What we need to do is this. Okay, and it is the same. So what we just did, and this width and height, you could also say this is a 6, this is a 40, you know. We're not using it so many more times, so let's just do that. And this, my friends, is just what we need to do. Right, so what we're doing here, I think this should be formatted somehow else, right? I don't know why this is not formatted in, so black. Oh, I made the font a little bigger. Usually I have it in this. So this is 80 characters long. This is enough, right? The other thing is that we are doing this string list. So we could just join. What would happen if we joined? What would happen if we joined this? What are we doing here? Okay. So this is just, let's do it in a different way. For I in range 6, print, instead of generating this screen and printing all of this, let's just print this, right? Exactly. Now we're talking. So now instead of printing this join of a list, could we do the join of a generator? Yes. If apps less than 2 or equal or less or equals 1, so let's keep less than 2, else dot. Okay, so one new lesson we learned is that I don't know, maybe that you can sometimes refactor code to make it very brief. This is something we learned. I mean, I was happy with a second part that was, what was it, 10 lines? Looked pretty good. But then suddenly you start reorganizing the thing. You say, okay, we can just print this line. We can just join this list. What would happen if we did not join? Well, I guess what would happen, we have a generator. So this generator, if we just made it a list, it would not be readable, right? We need to join. We really need to join this list. So what we're doing is for its row, for its row, we are doing this print either this character if the position of the X and this instruction compared to the J, which is the... So we could also do this for J in range. This is even easier, but then what happens is that we need to print this and equals this, and then we print a new line. So this, it has more lines, but it is easier to understand. It is easier to... Now we're getting back to where we were, right? It is easier to understand. So what do we want? Brevity? Do we want to be super brief, or do we want to be more understandable? We want to be more understandable. So this, I think this is better. And finally, of course, now I'm backtracking. You would do this, if this, print, you know, and equals this, else. But this I don't like so much, because this has a meaning, which is that you are printing, you have one print statement for its character. So that makes sense. And you have the end and this new line. Okay, let's keep it like this. There's many ways of doing these things. One thing we didn't comment, but we are all of the time thinking about is using the if blah blah blah. So X if blah 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 else Y, right? This construction. So one line ternary operator, I think this is called. In C++ you would have expression or condition, question mark, X, Y. This is what you have in JavaScript, what you have in C++, in C. This is good old C, but you can do this in Python. Okay, so maybe I think this is the sweet spot. We could put this into this generator, but I think this is the sweet spot. And we already saw that you can convert this to a one-liner. Let's go back. When was this a one-liner? Now I'm not sure where the one-liner was, but so the one-liner would be this, right? So the one-liner would be instead of this, we said we would dot join this, and here we could slash and join for I in range 6. Right, so this, I don't know if I had done this as a one-liner. What is wrong here? This is a generator, but this is not a generator, right? So what is generator operation? This join I don't understand. This join blah blah blah. This is not what I want to do. So is it this what we want to do? No. So we do this else this. Oh, I don't know what I'm doing here. So here I have for j in range 40. So I'm doing all of this for j in range 40. Okay, now. So the problem with this one-liner is that this one-liner ends up being 1, 2, 3, 4, 5, 6 lines, which are much less understandable than this 1, 2, 3, 4 lines, right? That is the problem with the one-liner. So in the end, I prefer just having the other thing we could do is this. Just keep a condition. And the condition str, yeah. So this is a boolean, but I wanted to be we need it to be a character, right? So we could map str to this. I don't know where we are. Could be here. I don't know. Anyway, we tried it, but I think this is the sweet spot, and that's where I will stay. Okay, one last lesson we learned. We need to find the sweet spot between brief and hacky and long and verbose, let's say. So not always verbose is better. It's nice to have 4 lines and not have 40 lines to solve this problem. If you have 4 lines instead of 40, you are signaling that this is an easy problem, that it is not that hard, and it takes less effort to read it, and so on. But at the same time, if you are able to solve it in a single line that is impossible to understand, then that is not a good idea either. So we will leave it here today. Thank you for watching, and see you tomorrow.